Hello, my lovely viewers. Welcome again to Mathematics and I. It is your favorite presenter, Jeff Naino, and today I will be teaching circle geometry, Theorem 3. Now, if you have been up to date with our previous videos, we've talked about Theorem 1, which has to do with perpendicular bisector. Also, we talked about Theorem 2, which has to do with angle at the center is twice the angle at the circumference of the circle. And today we shall be looking at Theorem 3, which says angles on the same segment are equal. Angles on the same segment are equal. Now, before I proceed, we are going to be proving how angles on the same segments are equal, and of course we are going to be giving examples. So if this is your first time coming in contact with questions like this or with a theorem like this, what you just have to do is to sit, relax, listen, and then you'll see how all of this works. Okay, now first of all, what brings about segments in a circle? Now, if I have a circle, if this is a circle, okay, don't mind drawing, and I draw a line here. Now, you will notice that this line does not pass through the center of the circle. Let's assume our center is here. Now, this line does not pass through the center of the circle. So it means this line actually divides the circle into two unequal parts. You will notice that here is bigger than this portion. So now, these two unequal parts are actually called segments. Okay, now the bigger part is called the major segment. The major segment. And then the smaller part is called the minor segment. Okay, so it means for there to be segments in a circle, there must be a chord that divides the line into two unequal parts. Now, how are angles formed on the circumference of a circle when a chord is drawn? Now, let us see. Alright, okay. Again, if this is a circle, okay, and then like we said, this is a chord. This is a chord. Now, if I draw another chord to this point, and then I draw another chord to this point, and then I draw another chord here, also another chord here. Now, this angle here and this angle here are the angles that are formed on the circumference of this segment. Remember we said from here to here is called the major segment. Now, these two angles are the angles that are formed on the circumference of the upper segment. And then if I again should draw another chord here, again I draw another chord, okay, and then a chord here, and also a chord here. Now, these two angles are also angles that are formed on the segment of the what? The minor one, the one down. Okay, now, according to the theorem, the angles that are formed on the same segment are equal to each other. So it means if here is A, it means here is also A. If here is B, it means here is also B. Now, why is it so? It is because both angles are formed on the same segment. On the same segment. Also on the same segment. So that is the theorem. So what we are going to do next is this now. How can we really show that A is equal to A? How can we prove it? Now, this is what we're going to do to prove this. In order for us to prove Theorem 3, we are going to be applying Theorem 2, which has to talk about relationship between center of the circle and angle at the circumference. Now, let's draw another circle. Now, if this is a circle, all right, and then we have this at the center of the circle. If this is the center of the circle, all right, and then we have a line here, okay, and then we draw a chord here, and then we draw another chord here, all right. Now, let us introduce an isosceles triangle. And how did we form an isosceles triangle? Is introducing two radius. to this point, and the other to this point. Now, this point, this dotted line and this dotted line are equal because they are drawn from the center of the circle. Both dotted lines are radius. So now, because this line and this line are equal, it means this point to this point to this point to this point is an isosceles triangle. Now, this is what we want to prove. Let us assume that this is point A, this is point B, point C, point D, and this is the center, point O. Now, angle AOD is equal to 2x. Now, let us assume that the angle at the center is 2x. Let us assume that the angle at the center is 2x. Alright. Now, if we want to look for angle B, now, only angle B. If we want to look for angle B, let us draw another circle so that we won't erase it. Now, if this is the circle now, and then we have the center of the circle, and then we have the chord, okay, and then we have our dotted lines here, and then also our dotted lines, and then don't forget what we are looking for now is angle B. So we're not going to be drawing angle C. So let's go. Now we have from here now down here, and then a chord here, and this is B. Here is A, O, and here is D. Now we said that the angle at the center is 2x. Now, using theorem 2, we says angle subtended at the center of a circle is twice the angle at the circumference. So if here is 2x, automatically it means angle B is equal to what? X. A, B, D is equal to x because 2 times x will give us the angle at the center, which is 2x. Now, we have gotten angle B. Next, let us look for angle C. Now, let's erase this. Let's look for angle C. Now, alone. Okay, we have another circle, and then we have this as the center, and then we have a chord, and then we have our dotted lines, and then also our dotted line. Now we are looking for angle C. Let's say this is another chord, and this also is another chord. Now, again, this is A, now this is angle C, this is angle D, and this is our center O. But don't forget, our center O is 2x. Now, if I am also looking for angle C, you will also know that here will also be x, because 2 times x will give us 2x, which is the angle at the center. So it means ACD is also equal to x. Now, from this simple comparison, you will see that angle B, which is x, is also equal to angle C, which is x. So it means, therefore, angle ABD is equal to angle is equal to angle ACD, which is both equal to x. So according to this diagram, it means angles on the same segment are equal. Because this angle is on this segment and this angle is also on this segment. So it means here is x and also here is equal to x. So this shows that according to theoretically, angles on the same segment, which is B and C, are actually equal to each other. So you see, this is the first part of the theorem today that we are going to be looking at, which talks about the proof on how the angles of the same segments are actually equal to each other. Okay, so now that we have done the proof, what do we do next? Let us solve some examples and see how we are going to get some answers. Now, without wasting time, Without wasting time, let's take a question. Example number 1. Find x in the diagram below. Now, we have this. Okay, we have a chord here now. And then we have a line. Alright, and okay, we have a line, a chord, also a chord. We have also another chord, and we have also another chord. Now, according to the question, here is 40 degrees, and here is x degree. And then the question said we should find the value of x. Now, without wasting time, here x is equal to 40 degrees. Now, why is x equal to 40 degrees? It is very simple. Applying theorem 3. X and 40 degrees are on the same segment. So, because of the theorem that says angles on the same segments are equal, it simply means x is equal to 40 degrees. Simple as that. Simple as that. Now, let us take a look at another example. Another example. Example number 2. It says find y in the diagram below. Find y in the diagram below. Now, this is what we have now. Sorry. Okay, now we have this. Also, we have a chord. We also have a chord here. And then we also have a chord. And then we have 2y plus 10. And then here we have 60 degrees. Now, we are told to find the value of y. But don't forget that this angle and this angle are angles on the same segment. So it simply means that the angle here, which is 2y plus 10, is equal to the other angle, which is 60. It is as simple as that, applying theorem 3. Now, 2y plus 10 equal to 60. We proceed like this way. Now, plus 10 crosses to the right hand side of the equation, so it becomes minus 10, collecting like terms. So here becomes 2y is equal to 60 minus 10. And of course, 60 minus 10 gives us 50. So for us to get the value of y, we have to divide both sides by 2. So when 2 cancel out 2, what I have left is y is equal to 50 divided by 2, which will give us 25 degrees. So you see, this is how you can actually show the proof that angles of the same segment are equal to each other, and also how you can apply this theorem in solving problems. With this, we have come to the end of today's class, and I want to say a very, very big thank you for staying with me, and I hope you have learned something new today. Now, if this is your first time joining us, don't forget to subscribe and also leave a comment in the comment section and tell us how you feel about the class which you just watched. Till we meet again in our next class, keep on watching Mathematics and I. And don't forget to follow us on Facebook, Mathematics Booster, on TikTok, Math Not Hot. Bye for now. God bless you.